All right, another help request for exercise 8.1, which is our PXY phase diagram using Rail's law. Okay. So let's just jump right into the code since we've already done a couple of these. Okay, so, all right, so this is the code as sent. So let me make this larger. Let me move my head out of the way, and let's take a look at it. Ah, you don't want my head big. Okay. All right. No. Sorry. All right. So let's look at it. So let's see. Up top we have comments. Okay. These are just like look like our input variables that you're using to call it. And so what I'll probably do is copy and paste that to script to get it running. But then I've got Railed. Okay. I'm going to have his inputs, Antoine. And this looks like a matrix. Where each row is going to contain my Antoine constants for each component, my temperature in Kelvin, then my reference px and y, which is the reference data I'm comparing to, stored as a vector. Okay, good. All right, so first thing I'm doing, so this is a pxy phase diagram, so temperature is constant and fixed. So with temperature fixed, that's equivalent to fixing psat1 and psat2, right? Because psat1 and psat2 are only functions of t. So knowing t is the same as knowing psat. And so what looks like you're doing here is you calculate psat1 and psat2. And so you pull off your Antoine equations for component 1, which is the first row of that matrix. Antoine coefficients for component 2 is the second row. And so if you look at your Antoine function, that's good. You unpack your constants, convert your temperature from Kelvin to degree C, perfect, and then compute. Looks great. Okay, so that's good. So then you create a vector of x values from 0 to 1 increments of 0.02. Then you create a vector of y and p's, okay, in which you're going to collect your calculated y and p for each x and store them. So that's good. Got a for loop. I'm going to loop over each x. And so the idea is at each x, so for each case of x, then I'll solve for p and y, right? Because x will be fixed along with t, and hence psat1 and psat2. And so I'll have two equations with two unknowns, y and p, which I'll use to solve. Okay, cool. So you're using an anonymous function to pass to your railed error function that nth x1 value, good, along with p1 set and p2, good. So my only unknown left is this y, which will be my vector, which will presumably contain y and p. So if I look at your error function, okay, just looking at the order x1, p1, p2, y, that's good. I unpacked y, so the first element is y1 and p, good. Good. Res 1, so you just have, this is underlined in red, just saying, hey, you might want a semicolon to suppress the output. So that looks good, all right, lowercase p. Then you pack it up. Okay, looks good. I don't see anything wrong with that. So then you come up with the initial guess for y. It's fine. P naught. So this is you actually analytically solving for the bubble point, but no worries. Okay. Good. And then solving. That looks fine. Okay, then I store y to my y vector. P I convert to kilopascals and store to my p vector. That looks fine to me. Then I plot x versus, so p versus x, p versus y. Okay, good. We'll have to see if the colors are case sensitive. Honestly, I don't know. You add your title. X label, Y label, that's good. Hey, you're printing to EPS files just like me. Hopefully you can open them on your computer. Then you're returning here, so what you're doing is, these are all row vectors, so you're transposing them to be column vectors, and stitching them together in a matrix so they look like a table. Then you plot your reference data. All right, so to me, nothing looks wrong. Okay, so I'm just going to save that. and I'm going to copy and paste this. Okay, so I'm going to copy that, and I'm going to create a new script. Once I paste it, let's see, there should be an uncomment button. Let's see if it works. Yeah, okay. And I'm going to call this, I'm going to suppress the output. Okay, hey, I guess you could even just put T here. Okay, and I'm going to save this, and let me just call it like railed caller. Okay, so then if I minimize this, okay, rail caller will just define my constants and call railed with that temperature and my, it's temperature, so you need a little more than that, actually, and your order changed here. So it's with first inputs Antoine constants, then temperature, then my reference values. All right, so if I call rail caller, let's see what happens. Things are looking pretty good. My guess is we probably just have, maybe we just have a discrepancy here in our units. Let's see. So my guess is, let's check your units. Something must be wrong. So this is your computed data. This is your reference data. Your reference data and computed data should at least match up with the endpoints. Okay, so here it looks okay. P2 sat looks like it might be where the issue is. Okay, so let's play with that. It might even be something incredibly small. And so let me just bring up even this. Let's check your Antoine constants. So component 1 is hexane, right? So we're looking at hexane, cyclohexane. So hexane 7. I could look at here. And 7.01051, 1246, 0.33, 232.988. Okay, that's good. Now cyclohexane, 6.85146, 1206.47. Okay, that looks fine. So let me look here. So Antoine T. So P1. So this is first row, all columns. So pulling off the first row is my Antoine constants for that Antoine call. And I give it my temperature in Kelvin. Okay, so then I unpack my Antoine constants for that component. I convert my temperature to Celsius. Pressure in millimeters of mercury is 10 raised to the A minus B divided by T plus C. So that gives me pressure in millimeters of mercury, which I then convert to pascals. Okay, so that gives me pressure in pascals. So it looks okay. Okay, let's look at your air function x1, p1, p2, y. That looks fine. I don't see an issue there. Plot of your reference data looks fine. Okay, let's look at your reference P's real quick. Oh. So ref P, okay, 77.327, yeah, 100.818. Reference data looks fine. make that B and G lowercase, just be safe. And let me run this one more time just to make sure. So the issue here is P2 sat. So what are you printing? So if this is our reference data, it would say the issue is just an Antoine calculation error. Okay, so I'm going to run it. Okay, and let's display, well, we can just return them. Okay, I'm going to return P1 and P2. Okay, so I want to call this, and we'll say M, then P1 and P2. Okay, so what I want to do is I want to run this. Okay, so now P1 and P2, they're returned in pascals. Okay, so I think the issue is P2 divided by 1,000 is 99.1745. Okay, this would suggest that it should be something less than 77, right? The pressure should be decreasing. Okay, P1 is going to be slightly greater than 100. And so that doesn't seem all that bad. So I'm thinking P2, right? So what I'm looking at is there an issue with P2 sat, my Antoine calculation for P2? Okay. So first thing is, let me just look at this range. So we're at 343.15. Okay, temperature is 70 degrees. So I could, in theory, use either one of these correlations. Okay, and so let me look at this again. Okay, let me just one more time. So Antoine constants, so this is for P1 sat, P2, 6.85146. Fine. 1206.47. Fine. Oh. 223.136. 233. 223.136. Aha. Oh. Okay. Bam. Now that graph looks good. Okay. So, what I had noticed before is, let me change this back. So you had 233 here. Okay. This is your predicted data. This is your reference data. So at the very least, your reference and predicted data should match up with the two pure component endpoints, right? Because this is just P2 sat. This is pure component 2, so that should be P2 sat. This is pure component 1, so that should be P1 sat. So they should match up with the endpoints. It looks like maybe this endpoint matches up, but this one definitely doesn't. And so that's why it was tripping a red flag to me of check your Antoine constants, right? It looks like something might be wrong with your P2 sat calculation. And it ended up being that, right, you just had a small, super small typo there that it was supposed to be 223. Okay, cool, right? Then it works. One cool thing that you taught me is that if I look back at your code, you had a capital B and G here for green. And I didn't know that this wasn't case sensitive. I just always have in my head MATLAB is case sensitive for everything. But apparently it works with the capital B and G. Okay, so good job. That's problem one. Yeah, other things you might think about changing. So I like EPS of files, so I open those up on my Linux computer all the time. If you want a vector graphic for Windows, PNG is typically a good choice. If I'm being anal, all right, KPA would be little k, big P, little a. All right, Pascal's the name of a person. But other than that, it looks good. Oh, and when you say hexane, cyclohexane, you could say 1 and 2, so you know what component 1 is, but those are minor details. But overall, good job. Just ended up really being a small typo in your Antoine constants.